Okay, let's quickly finish up number 5 from your more torque question sheet. I was trying to beat the clock, but I missed it. So this was ended up being 0.2733. That was part B. And part C asks, what is the magnitude and direction of the contact force at the base of the ladder? Okay, so we've been talking about the fact that the ground pushes up on the ladder and that the ground pushes with the force of friction on the ladder. The ground pushes with a y force and an x force, or a y component and an x component. And so this question is really just asking you to realize that these two are components of the force that the ground is actually putting on the ladder. So in the x direction, we have the force of gravity, force of friction, that you found. The force of friction was 267.79 newtons. And there's the normal force that you also found, 980 newtons. And so this question just wants you to find the resultant, magnitude and direction. So this is going to be the F of the ground, square them, add them together, take the square root, and you should get 1,015.93 newtons. And when you do the angle, 980 over 267, etc., you get an angle of 74.72, and that's going to be CCW with the ground. Okay? So that's all it meant. It was really just Pythagorean theorem, but I'm sure it probably messed a few of you up. Okay, so that's your homework questions. When I saw you in class, I gave you this sheet. I would like you to now find it, because we are going to just spice it up a little. Okay, so this time it's going to be a torque ladder question, but you need to find the mass of the person. Okay, so draw your ladder, and it says the mass of the ladder. I don't know why my lighting is going bad here. Yeah, I'm not sure what's up. Mass of the ladder is 10 kilograms. The length of the ladder is 12 meters, so this whole thing is 12 meters. And it's leaning against a building, creating an angle of 60 degrees. Student makes it 3/4 of the way up. Okay, enough iPad. So this is going to be FG of the ladder. And this is going to be FG of the person. There's no friction at the top. The R for the person, okay, it's driving me crazy. I can't even see what I'm writing, is 3/4 of 12. And it wants to know, and it tells us the coefficient of friction at the base of the ladder is 0.4, and it wants to know what's the mass of the person. So this is going to be F normal of the ground, this is going to be F friction of the ground, and this is going to be F normal of the house. Okay, and you're just solving for mass of the person. So my suggestion would be turn the video off or press pause, try it, and then come back and we'll do it together to make sure you got it. Okay, so pause me for a minute and try this. I'll wait. Okay, so hopefully you've paused me, hopefully you've tried. And so we're going to start like we always do, sum of the forces. I'd probably start in the y direction, equals MAY. And in the y direction then, we have F normal of the ground minus FG of the ladder minus FG of the person equals 0. And always you're trying to get an expression for F normal of the ground. So it'll be M of the ladder G plus M of the person G. But this time you cannot find this because you don't have the mass of the person. So then go to sum of the forces in the x direction equal to MAX, which is 0. And in the x direction, there's going to be the F normal of the house and the F friction of the ground. So F normal of the house minus F friction of the ground equals 0. Which means F normal of the house equals the friction on the ground. But we know the friction of the ground is equal to mu F normal of the ground. So that means F normal of the house is equal to mu brackets, and this is the normal of the ground, m of the ladder G plus m of the person G. And we can't find it because we don't have the m of the person. So now we go to sum of the torques. Okay. Is that better? Not really. Not sure what's up with this. So sum of the torques is equal to 0. So there will be a torque from the normal of the ground, a torque from the friction on the ground, a torque from the normal of the house, a torque from the ladder, a torque from the person. Let's pick our pivot point down here. These two will go to 0. This one will be positive, negative, negative. So R normal of the house, F normal of the house, sine theta normal of the house, minus R of the ladder, FG of the ladder, sine theta of the ladder, minus R of the person, FG of the person, sine theta of the person equals 0. Okay, this time we have the expression for F normal of the house, which we can fill in. So R normal of the house, and then brackets mu m of the person G plus m of the ladder G, and then still the sine theta normal of the house, minus R of the ladder, m of the ladder G, sine theta of the ladder, minus R of the person, m of the person G, sine theta of the person equals 0. Now you need to multiply through because you have an m of the person in here, right? And you got to be careful with your subscripts because they're going to be all different now. I'm going to pull my mu all the way out in front. So it'll be mu r, m of the person G, and then don't forget this sine theta. So there's two things in front and one behind you need to multiply by. Sine theta normal of the house. And then the second term from the bracket will be mu r, normal of the house, m of the ladder G, sine theta normal of the house. And then minus R of the ladder, m of the ladder G, sine theta of the ladder, minus R of the person, m of the person G, sine theta of the person. Isn't that pretty? Now, you're trying to solve for m of the person. You might notice that they all have g's in them, so you can cancel the g out. And then keep the two terms with m of the person on this side. So mu r normal of the house, m of the person, sine theta normal of the house, the g is gone. And the other term is minus r of the person, m of the person, sine theta of the person. And take the other two over, r of the ladder, m of the ladder, sine theta of the ladder, minus mu r normal of the house, m of the ladder, sine theta normal of the house. Factor out your m of the person. Mu r normal of the house, sine theta normal of the house, minus r of the person, sine theta of the person. The other side doesn't change. Divide by the bracket. So r ladder, m ladder, sine theta ladder, minus mu r normal of the house, m ladder, sine theta normal of the house, divided by mu r normal of the house, sine theta normal of the house, minus r of the person, sine theta of the person. Now isn't that fun? Now you got to get the right things in the right spot. So r of the ladder, it was a 12-meter long uniform ladder, so this is going to be 6. M of the ladder was 10 kilograms. And angle for the ladder will be this one here, so it'll be 30. Minus mu was 0.4. R normal of the house is the full length, which was 12 meters. M of the ladder was 10 kilograms, and this time it's angle for the normal of the house, the angle up here, so it's going to be 60, divided by R normal of the house, 12, angle normal of the house, sine of 60, minus R of the person, 3/4 of 12, going to run out of time.